to do it again. He was like, can you be friends up there? I was like, yeah.
Yeah, I know a good place that it has like 5 different styles of gameplay, basically. So
That's what I need.
Yeah.
I need to figure out where. We tried to do it last year, and then like with Tyler, when Tyler and Michael and Lola were still here, but
there's one that's like Capture the Hill, there's, or well, it's like they call it Crack House.
my mom and my sister come over here next weekend for my birthday, which has never happened in the history of time.
Did he announce me over there yet?
I would imagine by now, yes. We ran to the restroom, so. You may have just. There's a vest
Got
I
4
don't
of these.
know where.
Heartbreak and Jack faces.
It's relatively common as well as like there, you know? Just on the other side. Do you have a pen up there by you, by chance?
Yeah. I don't know if it works.
Thank you.
Just well, yeah.
So you're linked in your tennis player.
Yeah.
I play tennis too.
You got a league going on over here? I moved here in May, so I don't know a lot of people who play.
I live in San Antonio, so I did start doing a little bit of league a few weeks ago. I usually play a couple times a week just with a group of guys that I met up with.
Actually, I have a friend who's trying to make an app just for tennis players.
Yeah.
So they can
There's
sing.
find
been
each other.
some, I've
Yeah.
seen some, like Tennis Buddy or whatever, there's enough of that.
I
It's
have
just,
a good friend who competes a lot in San Antonio and here in Austin. He's
Yeah.
about our age. I could ask him. Text him and see. He plays like
please.
competitively.
Yeah.
Like still in kind of like club, I guess.
Is he in school?
No, he's like 30 something.
Okay. Yeah, I mean, that's what I need. I'm
Yeah.
not-
I will.
Like I played
You're
in
pro?
club at UGA.
Yeah. Yeah, cool.
My roommate now, Boston, I've never played before, so.
No, that's boring. Yeah, that's how I feel about the volleyball.
Just,
Hi guys, welcome. I'm gonna go and get started. It's a small classroom, so feel free to just talk and ask questions as we go along. I don't know, let's get a gauge of the room real quick. How many people here are developers? How many of you want to learn about the architecture and how to set up and get started on Hyperledger?
Yeah.
Alright, that's not what I'm gonna go over. I'm gonna start kind of with the basics, and then, you know, honestly, to not waste your time, I'll cut it off before an hour's over, and then if you have development questions, I'll help you in any way I can. But we'll take it kind of to the side and show you how to get started. And there's links at the end too for, you know, if you have follow-up information on how to get started with chain code and things of that nature, then you can just take a picture of the thing and go and get started. So first and foremost, let's dive into kind of the whole point of blockchain. Some people have already come here and me just sitting in the back are asking the difference between, you know, public and private blockchains, and you know, why is there all these different sanctions of different startups like Ethereum and all these Bitcoin spin-offs like Factum, and the answer is because we don't really know what we're doing yet. And that's kind of how we're trying to figure it out, is offer all these different choices, and whatever comes out as the de facto leader, we're kind of hoping everybody gets behind. And that's part of what the Hyperledger project is. But you know, taking it back a little bit, blockchains are all about the business network, right? It's about having this shared database amongst all these different members of your network, so that everybody's kind of on the same page in terms of the information that they need, but they also have like controllable access to the information behind the scenes. Markets, that's kind of a, these couple of slides here are more of a unrelated to blockchain. It's kind of the reason why blockchain started in the first place. But The markets here thing is something I like to make a big point on, is the public and private debate for markets translates directly to the Bitcoin public and private debate. If you have a public blockchain like the Bitcoin blockchain, you can put anything in it. There's no credentials to get in. That's why there's this op return problem. There's all this data just getting flooded into the blockchain that a lot of people are concerned about the size of that, and having all these nodes running that full blockchain is getting to be it's a bear, downloading 75 gigs of data every time you need to spin up a new node. So that's why IBM and Hyperledger in particular are trying to get into that private space. So basically you get to control exactly what data gets stored on the blockchain. You get to define those data objects, and then you can control who joins and gets to add and subtract and make changes and add smart contracts to that ledger based on the membership services that Hyperledger offers. All right, so in your business network, the way wealth is generated is through transferring assets. So maybe you have the supply chain, and the transferring of component parts eventually makes a product, and then you sell that product for a profit. And all along that chain, there's wealth being generated. There's profit being made for markups. There's things of that nature. And the assets that get transferred can be defined in two main categories. There's tangible assets, like in your supply chain. If you have microchip parts that are coming together to make a microchip, they're all physical assets you can transfer. But then there's intangible ones. The example here is a mortgage. So this is a piece of paper. It doesn't mean having this paper gets you directly into the house. You have to have the key. You have to be at the house. But you can digitize ownership, right? And that's kind of where blockchain is taking it. We have all these assets that are being shared on ledgers. If you divide them up and then try and digitize the ownership of these assets, then we can kind of dictate who owns what at any given point in time. Intangible assets, they subdivide. There's financial ones like your bonds and your intellectual assets like patents, digital like music, and then cash. We're trying to digitize cash. There's some ongoing work right now with some governments as well. So blockchain is obviously all about the ledger, right? It's like the example they provided. If you can replace blockchain with database and there's no real difference between your application, then just use a regular database, because blockchain is just a convoluted way of doing that. But the ledger itself, it's been around for a long time. In businesses, it defines what your business is. Like you have assets on your ledger. Maybe it's intellectual property, maybe it's you're a manufacturing company and you have machinery, and the summation of all the assets that you own is where your business is at. That's your standing. So debits and credits to that ledger is what you do in the course of business. That's how you raise money, that's how you get profit, things of that nature. Those debits and credits are transactions. And typically you're looking at double entry bookkeeping as the way to maintain all of this. But if you fast forward to the future, when everybody's on a shared ledger, then the double entry bookkeeping concept kind of goes away, because immediately as transactions are validated across the network, then everybody's ledger gets updated appropriately. And then contracts. So contracts are basically the rules, the stipulations for the transfer of those assets. So all combined, the ledger, which stores your assets, is updated through transactions, and those transactions are governed by contracts.
Is this presentation, can we get the copy of this presentation afterwards, or?
I can send the deck out, yeah.
Thanks.
You just put it on the Slack channel for the blog?
Yeah, we can do that for sure.
Thanks.
All right, so, and then
Does
comes
the contract
blockchain.
happen first and then the transaction? Do they do the contract first?
Typically, yeah. If you have a complicated, so the example they gave here, right? If you're going to go buy a car and you want to stipulate that the car's to run before you pay the money, then the contract was made before the transaction was done. So, yeah, short answer.
Is it a separate instance, or?
Are you referring to like a blockchain contract?
Yeah, so the contract is tied to the transaction, correct?
Yes, so the transaction as it comes across the network is going to run through the smart contract logic.
Okay.
So you have to have that contract in place so that when the transaction comes, it knows where to go, what to do, how to add or subtract information to the ledger, things of that nature.
So like the contract is the business logic for the transaction?
Bingo.
Okay.
Does that contract exist outside of Hyperledger or inside of Hyperledger?
It'd be inside. If it's outside, it's vulnerable, it's risk.
Okay.
And you want each node to be able to run their version of that contract so that if you have a malicious version and you're trying to tell the rest of the network that your version is correct, they need to have their own independent version to be able to tell you, no, quit trying to hack my node or whatever it is that you're trying to do. All right, so that's kind of where blockchain steps in. It's the system of record. It's the ledger for your business, fundamentally. We can kind of see a little network diagram here. Shows some inefficiencies. Everybody's got their own ledger these days, and they have to all maintain their own copy of the database. They all have to have secure access. They all have to have admins. They all have to have people support that. It's expensive, it's inefficient, and it's vulnerable. If party C down here gets hacked, all the business transactions that they've done with the rest of this network is now at risk of exposure and their positions being leaked to the world. But if you have a blockchain, and all this is replicated, and you have very high type security protocols in place to make sure access from party C is governed in the same way access to party, or the bank or the auditor, then we start to see a lot more improvements in security, in reduction of time and risk involved with maintaining these ledgers. There's a couple of really big words in the blockchain space down here on the bottom right. First and foremost, consensus. So I feel like everybody here who is familiar with Ethereum or Bitcoin has heard of proof of work or proof of stake. Those are your consensus protocols. And all consensus is basically a method of keeping the database in sync. So if a transaction comes across one node, party C down here says, it looks like a shipping line, they send a transaction out that says my package has arrived at the port and my business is done. They send that notification out. The rest of the network is going to, because it's a distributed database, receive that transaction. They're going to run it through their business logic, their smart contract, and they're going to basically communicate with everybody else and say, are we all on the same page? And if enough people say yes, then it's committed. And that's all it is. They don't care what the data is. They just want to make sure everybody else is on the same page as them. And so there's protocols of going about doing that. It's basically a series of messages back and forth along this network.
How comfortable are these institutions to share the data with every other node?
Oh, it depends on what the information is.
Okay.
Which is why we view private blockchains as so important. Because if you have an architecture whereby only certain information is released, then you can still maintain your own business confidentiality while simultaneously reaping the benefits of having a shared database and the security and the efficiencies that come along with it.
Go ahead.
What is the size of the data stored for a transaction in the blockchain?
There's no one answer for that. It's however big you want to make the transaction.
Okay.
You'd have to consider the implications of how much data you want to store on a blockchain, because keep in mind every node has a copy.
Yeah.
So that can get expensive to maintain. You can have a lot of database size requirements. Maybe you have as your consortium here has a latency requirement, because you're only as fast as the slowest node, because you all have to commit. But there's ways of managing size, whether it's you take a snapshot of it and use Merkle trees to basically point to a new starting point of a database and then kind of push the old version of the database out to the cloud. And if anybody, for maybe you have an auditor requirement, a regulatory requirement that says you have to maintain 7 years of transaction information on your ledger. Well, maintaining that is going to be expensive, right? And you don't want to maintain 14 years of all of that on your blockchain, so everybody's burdened with that data. You can just take that regulatory snapshot every 7 years, have a contract that sends it off to, what's it called, Snowball, I think Amazon has a big data store service, and say, look, auditors, if you need 7 years prior transaction information, you can go there, but we're now on the next 7 years.
On the previous slide, if a hacker got into Party C's records, they would have Party C's records. In this scenario, if a hacker got into Party C's records, they'd have everybody's records.
If it's a kind of like a public if all the data is shared amongst all of these people, then you're right.
So how does it make it safer?
Well, it becomes a consortium burden to have the
For
security
security,
requirements.
okay.
And when we look at the real, goose egg, golden egg of blockchains, it's being able to have identity that is tied to the blockchain as well, but also tied to your physical person. So that when you do access the ledger, you have the appropriate credentials to do your job, but anybody else who tries to impersonate you is going to fail.
Is there any way to force other parties to abide by the, whatever's decided for safety and security? Like, is it like the blockchain carries that, or is it everybody has to agree?
I'd say everybody would have to agree. The blockchain doesn't necessarily, there's a membership service in Hyperledger right now. And that membership service is basically just they give you credentials. They give you certificates is what it is.
Mhm.
And they're like a VeriSign, essentially, is what that is. So there's inefficiencies there, and there's imperfections, and there's risks, but we're chugging along trying to get it as best as we can.
Right.
Any other questions? Oh, more words.
Provenance.
Provenance, yeah. Consensus being the method that keeps everybody in sync. Provenance is the breadcrumb trail of transactions that makes up the the current state of the database. So if you look at Bitcoin, the history of all the transactions in the network eventually culminates in a state, right? And that unspent transaction output kind of breadcrumb trail is where provenance is so valuable. It allows you to replay the history of transactions at any given point in time and be confident that nobody's going to be able to mess with that. And why are you confident nobody can mess with that? Because of immutability. This is a ledger that doesn't allow rollbacks. It's a append-only ledger. So that if you have a breadcrumb trail of transactions, you have consensus at any given point in time, and you have the immutability that doesn't allow you to make changes and alter the past, then you're confident that the final version is what you're looking at. So real-time updates, you have everybody in agreement of the current state, and we're all happy. So Bitcoin, pretty sure everybody, we can all thank Bitcoin for the blockchain architecture. It was the start of everything, and unfortunately, this is the opinion of IBM. We can't, as an enterprise company, say with confidence that our customers should use the Bitcoin blockchain, because we don't have enough control over that, right? And there's risks that come with a public blockchain that is now becoming more and more centralized as we look at the Chinese takeover of the mining nodes. Obviously, we wouldn't be here without it, but we always like to distinguish that Bitcoin and blockchain are distinct technologies. Bitcoin is an app. Blockchain is a type of database and architecture. Every blockchain startup out there is taking the basics of the blockchain and kind of spinning one of these boxes or multiple boxes. Because fundamentally, the blockchain is a shared ledger that everybody has a copy of. We've talked about that. It has smart contracts. These are the business rules for which updates to that ledger are valid. It has privacy. That's an important distinguishing factor of where we see blockchain going, because you have to have those contracts that are kind of hidden from the other members of the network. And it has consensus, which we've talked about already, just the methods to keep things in sync. When we got started with the Hyperledger project, we kind of did a survey of what was out there already. And what we found was the existing blockchains were suffering from these things right here. There's limited throughput. The max transaction processing speed of the Bitcoin blockchain is 7 transactions per second. Poor governance, so there's no way for anybody to control the data access protocols. There's no privacy. Confirmations were slow, so that finality aspect, right, that we talked about a minute ago, is restricting or being restricted by the existing blockchains because of the slow transaction confirmation.
Is chip and pin on this?
One more time?
Is chip and pin still on the system?
Chip and pin?
Yeah, for your credit cards.
I don't think that's on the blockchain.
was just curious.
Yeah, those are all maintained by the companies who, the Visa, the payment processors. Anonymous processors. So when you're trusting random people to keep the network up to date, and they're designed for cryptocurrencies, which in a private network aren't necessary. Cryptocurrencies are an incentive model. It's an economic reward for being honest, which is why proof of work has succeeded.
Quick question. When I try to explain this to artists, I just tell them like it verifies itself, and then it has this like Satori moment of clarity, and then somehow a coin comes out, and it's kind of like, can you explain that to me again?
Sure. With Bitcoin, the confirmation of the mining process is, it's basically like somebody posts a lottery number on the board and then says, I want you to give me this lottery number back. I want a matching number, but I want you to show your work. And getting that number is very computationally expensive. You have to go through a whole bunch of mathematical hash functions is what it's called. And if you get that number, you basically you just won a lottery. So you yell to everybody on the network, I won the lottery, look, my number's matched, and here's the proof that I have. This is how long it took me to do it. And everybody gets that information, and because they're all competing for this lottery, and they go, ah, crap, he beat us to it. We'll take his and start working on the new number. So as soon as he broadcasts that information, a new number pops up, and everybody else starts attacking that. The reward for matching that number is Bitcoin. So basically, when you announce to the network you've solved the problem and you've matched the number, you also say to the network, all right, now give me, what is it right now, 15, 12 and a half Bitcoins? I think it's 12 and a half.
Okay.
And then you get that, and then you just continue on with the process.
So the network, the blockchain delivers you like automatically to your wallet, like, okay. I see.
It's called the Coinbase transaction. So whenever you broadcast that you solved the lottery, and you match those numbers, you also include your wallet location, and you say, give me the 12 and a half Bitcoins that is part of that Coinbase transaction. And then that is the basis of the new block that people start buying.
But there's only so many blocks that you can make before those coins run out, right?
Yeah.
I see. So, do you set the block amount or the coin amount first?
Let's talk about this later. Yeah, after the presentation, we can sit down. Unless everybody here wants to hear about
Pretty
that.
fascinating, but we don't wanna hijack here.
Yeah,
Yeah.
sorry. Sorry.
No, it's good. It's
No, it's
good.
good.
I appreciate the discussion. I just, we got to make sure we get through Hyperledger before we get to Bitcoin. So, what is Hyperledger? It's a collaborative effort to advance blockchain technology by identifying and addressing blah 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 blah. It's a open source project that we're trying to make the basis for the new blockchain paradigm. TCP/IP was kind of a consortium thing. Everybody adopted TCP/IP as the internet layer of communication, and that's kind of what we're doing with Hyperledger, the easiest way to describe it. You have the internet existing already, but now we have a new need for an internet of value, an internet of transactions. And if we can nail the protocol specs for that, then everybody can just kind of know that it works, not even have to deal with that layer, and start building even crazier things on top of it, just like we did when we got into web development and e-commerce. Project goals. So there's 4 main goals, right? It's an enterprise-grade framework and code base for business transactions. Basically, we want to build the enterprise version of a blockchain. We need to create a technical community, promote participation of the membership, and host the infrastructure. This is kind of the goal of the Linux Foundation's Hyperledger kind of parent. We wanted a modular framework. Like I mentioned, those building blocks of a blockchain, consensus, the ledger, the privacy, and the smart contracts. All of this should be at the control of the people who want to make this network. We're not going to say you have to use proof of work. We're not even going to say you have to have consensus. We're going to give you the framework of communication so that you can plug in the things you need for your use case. If you want proof of work, say you have a whole bunch of, you're making a public blockchain, then use it, plug it in. But if you have a 12 bank closed network that's private, you only need certain levels of consensus because you have to have a larger transaction processing speed. So that's why we wanted to make it modular, so that if you had a different use case, you can apply it to that use case. You don't have to get stuck with the burdens that come with a big public blockchain network. Questions? So Linux Foundation is the governance body for the Hyperledger project. These are some of the projects that they've governed before. Node.js probably being the one that I was most familiar with. They are, here's some of the numbers. When they announced that they were going to be the governing body for Hyperledger, this is the initial reaction that they got. Now they have well over 30 members. This is an outdated slide. But this number was what surprised me the most. 5 times more requests than the next largest in Linux Foundation history of people who were interested in joining the Hyperledger project. So that's pretty cool. Here's some of the players. As you can see, there's some major names up there up top. My company, IBM, Intel, JP Morgan. There's some general sponsors. It's primarily the distribution is going to be financial service and tech companies. Right now, it's where the most interest in blockchain currently lies, and the most money for it.
Good question. So Hyperledger runs on blockchain, or is it
It
new
is a blockchain. Yeah.
So it's a new
Yeah.
a new thing.
Mhm.
I have a question about, so all of this stuff that you were saying at the beginning about immutability, consensus, I understand why that would encourage, in the smart contracts, why that would encourage people not to cheat or commit data that's not truthful, but for instance, in the supply chain example, what really happens or is stopping people from committing, like, poor integrity data? Like, if you're dropping off this
good
amount,
question.
can you say, oh, I'm supposed to drop off 100, I'm only dropping off 50 of this thing?
Right.
What is really stopping?
Nothing. It's garbage in, garbage out, same as any
Right, so then
application.
if garbage goes in, then what, then what
Where's the
happens? Especially if
accountability?
Yeah.
especially if everyone's agreeing to like a hash, they're not seeing the data.
Sure. Basically, what you would ideally do in the supply chain scenario is take it out of the hands of people who can make mistakes whenever possible. So you have a smart chip, or you have a QR code on the box, or you have some way of handling this so that there's no fat finger mistakes and things of that nature. But there's no system that you can make that is guaranteed not garbage in, garbage out.
Right.
You can do everything in your power to make sure the transaction is validated. Say there's a ID for a container of shirts. There's 100 shirts in a box, and the shirt manufacturing company says, okay, so we're shipping this. We've got 100 shirts in this box, and we're going to put that information onto the blockchain. So that transaction ID is now tracking all the updates made to this box of shirts as it goes along. And so say they hand it off to FedEx, FedEx hands it off to UPS, and UPS takes it to your door. That wouldn't really happen, but bear with me. When UPS gets it, they scan it and they say, all right, there's 10 shirts in here, we're gonna ship it off. It was a fat finger mistake, you forgot a 0. Well, that transaction ID is what's important. The information below is not quite. So there can be a contract that checks, okay, is this transaction ID? Yes. Okay, now what is associated with the transaction ID? Oh, 100 shirts. You said 10. This transaction is not valid. Please try again.
So basically, the integrity of information committed is very tied to the identity of the last person that committed this.
Yeah,
ID.
and that's
so the last person
not
that
it.
handled it, you can tell by the blockchain, and so that's why that person can commit that data.
Sure.
So in that scenario, the shirts that is a Bitcoin, in order to see like the history of what's happened with it.
Yeah, if you want to think of it as Bitcoin, you're trying to transfer 100 Bitcoin, you only have 10 in your wallet. that's not gonna be valid because the transaction IDs that led to the culmination of how much Bitcoin you have in your wallet reflects that you just only have 10.
Right.
Yeah.
So this technology is best suited right now in spaces where the smart contracts can be very explicit and things can be quantified.
Yeah, and we can get into smart contract and the separation of concerns between that smart contract layer and maybe your application layer, because smart contracts they're expensive to run.
Yeah.
Everyone has to go through the smart contract logic if they want that transaction to be validated.
Yeah.
So what I have to struggle with when I sit down with customers to build POCs is, all right, yeah, you want everything on a smart contract, but you don't need everything on a smart contract because it's going to be a burden, that's going to be a bottleneck for you to get the transaction processing speed that you want. So what can we put on the smart contract layer that everybody has to execute, and they have to do it, or else the integrity of this whole system falls apart.
It's a POC.
Proof of concept.
Proof of concept.
That's what I'm thinking about. I work in semiconductor development for my day job, and I'm thinking there's so many moving parts, it seems like this would be more of a burden.
Yeah, and when we look at blockchain right now, it's not ready for the high transaction per second processing. So it can't do the Visa, MasterCard kind of payment rails yet. The latest number I saw in July from an independent person trying to maximize the transaction per second of Hyperledger was in like the 40s or 50s transaction per second. But we're getting there, right? So if we can make it as efficient as possible, and hopefully you guys who are developers here can help with that process and contribute to the open source project, then we'll start to see that enterprise scale come out. We're getting the goal for actually the end of this year is 100 transactions per second, and I think we can do that.
I got a question. Like when I think of contracts, I think of like, a sea of words lawyers throw together. How do you like translate that into like some code?
If then else statements.
Yeah.
Yeah, but
It's the same logic.
the basis.
You
of
can't-
like,
you
it's
can't
like, how
see-
do you take words and then say that's a what I mean? Like,
We need to get, that's when you get into the
definitions.
legality of smart contracts and how they're gonna hold up in court. And we simply haven't had enough of an opportunity to experiment with that to know the way it's gonna work.
so there's not precedence.
There's not precedence, bingo. If you're having very complicated contract logic that would require lawyer intervention kind of thing, then I'd say hold off for a minute, because there's other companies that are trying to build blockchains that handle natural language and things of that nature, like Corda,
Yeah.
which is the R3 blockchain that they're trying to build.
But ideally, it would hold attorneys accountable too, because the contracts are not built on natural language, they're built on they're supposed to be built on formal logic too.
Right. Yeah, and that's
Yeah, but
that's what we would like to
They
see.
don't, they don't, but.
Purposefully complicated. So
I mean, you can.
got
I mean, look at what
lawyers.
happened with the Ethereum hack recently, right? And the implications of that in a court of law. If what they are demonstrating is we can fork Ethereum if something bad happens, then maybe some government will come in and say, look, there's a application running that is on Ethereum and has been maliciously tampered with. Now we need to, as a court ruling, fork Ethereum. Well, the whole point of that public blockchain is that no one party has the ability to dictate where the fork goes. You have to have the whole mining power behind it. So there's implications there of the legality of smart contracts and being able to change the, these fundamental tenets of immutability, right? Finality, provenance, history of transactions, all these things that build up and make blockchain so unique and valuable is we can't get rid of that. Can't give that power to one legal body. So we'll see what happens. It's kind of an interesting world, law and smart contracts.
Question. So you're talking about transaction rate. In Bitcoin, the answer to that is payment channels and like Lightning Network. And Ethereum has their answer to that is stake channels, where it's very much like the Lightning Network, just with smart contracts and way more powerful with settlement on the blockchain. Does Hyperledger have any research along those lines?
We don't have a Lightning Network yet. Ideally, we would need that. Ideally, we would construct if you wanted to do payment processing on the Hyperledger blockchain, you would construct the entire thing to be able to handle by default 10,000 transactions per second, like the Visa network handles. And you would have a private or permissioned or any kind of blockchain that you want to facilitate that payment rails and have that blockchain just handle that. We don't see, you know, Lightning Network was kind of like a patch. You put a Band-Aid on a thing that couldn't handle anything more than 7 transactions per second, but had to scale out. So let's build something separate that kind of plugs in through that, you know, that final settlement process. It gets put on the blockchain of Bitcoin, right?
State channels are Ethereum's answer to that, so it's a smart.
I would need to do more research into state channels. Honestly, I'm not familiar with their proposal there. But I'm glad to see that they're addressing it. Because what's, I think Ethereum's max transaction per second speed is like 22, I think, 23. I remember seeing that number somewhere, but I could be wrong. All right, so Hyperledger right now is in incubation, which basically means we have 2 base projects, and we're trying to decide which one is going to be the Hyperledger project. The fabric that I've been referring to for most of this discussion is what IBM, Digital Assets, and Blockstream combine their code bases to offer up to Hyperledger. And then Intel has their proposal, Sawtooth Lake, which honestly I haven't done quite enough research on, but it's kind of, I'm pretty sure it's just a public blockchain as well with some unique features. The scope of Hyperledger kind of falls into this area. It's basically the shared ledger technology I talked about before. It's that protocol layer that contains the code execution environments, the data structures, you know, all the things you see here. What we're not trying to get away and handle as part of this project is basically applications on top of that layer. So we say we're going to remain use case agnostic, data agnostic. We don't care what you put onto the blockchain. We're just going to give you the means to do it. So a quick, very simple architecture diagram for what a blockchain app could look like. Down here, you have the chain of transactions. This is your breadcrumb. This is your chain, your blockchain. And those transactions all sum up to a world state. So if you're looking at the world state, you get to see everything, you know, everybody's state, things of that nature, the data that you're allowed to see. It's basically like a regular database. As a matter of fact, it is a regular database. It's RocksDB. But we also keep that log, that history, that breadcrumb trail. Rocks, R-O-C-K-S-D-B. We also keep the chain so that when you're looking at that world state, you can always replay anything that you are confused about or in doubt about. So you guys as developers this weekend are the little guy up there on the left. You're going to be building the smart contract logic, and you're going to be building the application layer to interact with it. When you look at Hyperledger, the access to the underlying blockchain down here is done through that smart contract layer. So if you're going to make any updates, you have to pass through that logic gate to get you to do so. Blockchain itself can send out events. So if you're trying to do something that fundamentally is relying on the state of the blockchain, then you can have ways of emitting the information that you need. And then you can access directly through your application by calling some of the REST APIs, but you can't make changes to the ledger through that application layer. You have to go through the smart contract. Chain code, like it says down here, smart contract is implemented using chain code. The chain code main methods that every chain code is going to have when you deploy it are invoke, query, and init. Init gets called every time it's spinning that up. Query is obviously if you want access to the data of the blockchain, you have to have that method, and then invoke. Invoke is what allows you to get or to put or delete or change or update or any of that nature is in that invoke method encapsulation.
What's the query do again?
Lets you read the data in the blockchain.
So specific query for gets?
Yes, so you can further subdivide query into
Right.
More intricate.
How can you do a delete though if it's immutable?
Well, it just deletes the key value pair. There's still the history of it.
Okay, there just won't be into the future.
It's like an unsubscribe,
Yeah.
where you
yeah,
have a
bingo.
subscribe, but you never delete. You always just unsubscribe, which overrides when you go to use it.
So it would still be in everybody else's blockchain?
Oh, yeah.
It
Well,
just means
no,
you don't
no,
have
it
it
would,
in
it would,
yours.
it would be deleted from the world state.
All of it.
So like, you won't, you just, if you delete a record, now nobody really cares about that record today, but
But you
if you
look
wanted
at
to
the
go back and
history.
see that it existed, you can still do that.
With a query?
Right.
Okay.
So as a developer, if we're developing apps for this, we're really worried about the application layer down to the smart contract, right? Because the smart contract's gonna be what interacts with actual Hyperledger.
Yes.
Okay.
Yeah, you don't have to worry about maintaining the history of transactions or all that. It's just, that's automatically handled for you through Hyperledger. That's kind of what the whole thing is about. We don't want you, I don't want a developer to deal with what's happening down here. You shouldn't have to. That should be solid. And thinking about the underlying, you know, what's behind the curtain is just, that's a burden. And just be creative and make the next application that everybody wants to use.
So is chain code an API?
Chain code, you can interact with it through API, yes. It has that layer of interaction, but it is not an API.
Is that how you interact with the ledger?
Yes, that's one way, yeah. You can just make API calls, REST API calls.
Okay.
And I'll have links to documents that you can read more on how to do that, exactly what that looks like.
Yeah.
Things of that nature if you want to dig a little deeper.
And what can we learn about is it use tokens or how does it authenticate who's making the call, who's doing the put, deleting?
Yeah, when you spin up there's basically a YAML file that has a list of usernames and passwords. It's still in beta, so we haven't really polished this to make it look
Okay.
like a real enterprise level access control policy. But you would have to log in. You have to authenticate. So you would send that REST or that API call with the username and password that you want to log in as, and your chain code could have checks and be like, is this user trying to access this method? Yes, they can, or no, they can't, based on the credentials that you provide.
Okay, and that's in the ledger's kind of like user table or whatever?
Yeah, there's just a file that has that, that's part of the membership
YAML
service.
file.
Yeah.
Right. Okay.
So here's sort of another diagram of what Hyperledger is offering. At the top, that's kind of your communication channels through the API, SDK, or the command line interface to interact with your membership service, your blockchain service, get information about the transactions, and access your chain code. So that's your interaction layer, and then what those are made up of is down here. Your membership service is, you have registration, you have identity management, auditability, things of that nature that factor into your service there. The main blockchain service is your peer-to-peer communication protocol, the consensus manager, the ledger itself, storage of that ledger, that's your RocksDB, and then chain code services. So every time you spin it up, it's in a secure container, and a secure registry of where that container is located, so you can make calls to that chain code directly. So that's basically it. If you want information about Hyperledger, this is the main Hyperledger website. It's hyperledger.org. Go to the community, go to the GitHub, check out the Incubator if you want to see Fabric or Sawtooth Lake. If you want to get started as a developer using it, you can go to the docs page. That'll be the first place I recommend you going.
Yeah.
So that you're always familiar with where to go back if you have questions. Join the Slack channel. There's over 2,600 members. So if you have questions, you can post on there. And chain code, that's usually where everybody struggles. Chain code is that smart contract language. And right now, the most supported language for writing chain code on Hyperledger is Go, which is not a very common language for people to know. In the next couple weeks, there will be Java support. It is my understanding that you can write chain code in Java today. It's just not as easy and supported as Golang.
We, this Go.
Yeah.
How's the documentation? Are there tutorials?
Yeah,
Are
so
there some
learn
place-
chain code is a good tutorial to get you
Okay.
started on what
The
a,
basics.
yeah. It goes through the invoke, it goes to the init, and it goes to the query, what
Mhm.
exactly that entails, and it gets you started with hello world, so that you know the basics of interaction with the fabric as well.
Okay.
Any questions? Cool. Well, I'll let you guys go. We can talk Bitcoin if anybody wants to stay and ask questions about that.
I kind of wonder how this happens in applications. So everybody has the same file, or what, in order to, yeah.
Business logic.
Yeah, how, well, I'm kind of wondering about the setup, and we've talked a lot about, what it is, but how does it look in application? What is it, and what is the setup like?
So you get a network. Where is it?
Because presumably we're gonna go back into that other room and try to set one of these up, right?
If you want.
I
Yeah.
mean, for shits and giggles.
So this is kind of what it would look like, your blockchain network. That architecture diagram, I want you to keep that in your head because that's one node. All right, and it's
Which diagram?
the one with the database on the bottom.
Yeah.
The smart contracts.
Gotcha, that's one node.
That's one node.
Okay.
So when you build your application, each of those nodes are reflected here. So you have this network, and you have interaction between these nodes through, I think it's gRPC messaging, publish, pub sub kind of stuff. I don't know, we don't have to get into that.
Okay.
Honestly, I wouldn't be able to talk much about it anyway.
Fine.
And what you have is at this application layer, you're going to be invoking that smart contract. And every member of this network is going to have their own application layer, their own login. Let's get an example. Say you're the DMV, and you're issuing manufacturers, what's the VIN numbers? And the DMV is the only place that you can get legitimate VIN numbers as a vehicle manufacturer to put on the car to allow it to drive on the road. So the DMV has to keep track of that. They also have to keep track of who received the VIN number and what car it's on. So but they don't make the cars, they are relying on the manufacturer to give them that information. So let's say there's a blockchain network. You have the DMV here, you have Toyota here, and what they do is the DMV has the ability on the smart contract layer to create a blank vehicle template. It doesn't have any make information, doesn't have any model information, doesn't have any manufacturer information, it just has that VIN number, right? That's your transaction ID, you can think of it as. And that's gonna follow the car along in the network. So basically they say, all right, let's make.
Well, it's not with a car yet, it's just a number at this
It's just a
point.
number.
So it gets to be
that-
another car at the Toyota plant.
That the DMV owns. So they own this
The
car
number.
at this point. It's a non-existent car, it's just an ID.
Is it, yeah,
But it is the
Little-
basis of a vehicle.
right.
So they own this record, nobody can do anything to it until the DMV releases 10,000 VIN numbers to Toyota. Now Toyota has smart contract language, which everybody gets to, they all have the same smart contract. So they all know the logic that exists and they know what they can and can't do. So now that Toyota has these 10,000 VIN numbers, they can append make, model, color, year, all the things that make up the full definition of a vehicle, and then they're done.
Is the contract kind of like a schema for what's required? Like you're saying a lot of properties, right, associated with this ledger. Is that the deal? It's gotta
In
have a
this
make,
smart-
it's gotta have a model, it's gotta have a color, it's gotta
Yep.
have number of doors, not like.
Business object definition is part of the smart contract.
What else is part of the contract?
The ability to make changes to that business object.
Well, that doesn't make any sense.
So if you, in your smart contract layer, you define the asset of the network in that application is going to
Yeah.
maintain. So that's the VIN number, the make, the model.
Mhm.
And then below that, you have invoke, query, things,
Those
those
chain
functions
things. Yeah.
that are going to make changes to that fundamental business object. All of that is maintained on the blockchain.
The
Any
ability to
updates
make
to it.
changes to it.
Yep.
So I guess if someone painted the car another color, say like, oh, this property's changed to blue now.
Yep, if you have the authority as the owner to make changes, like, no, you take it to somebody to paint it for you.
Right, and they would do that.
They would have, a credential to log in this application
So
that
give
gives them the
just
right
unique
to
right
just
change the color.
change the
All I
color.
can do is change the color.
Yeah.
I'm the color guy.
Yeah.
All right.
So as ownership of this vehicle passes and the rights to make changes to it, that's kind of where that smart contract layer becomes very important.
How do you hand off the rights to make different changes to the contract?
You build, it's basically, right now, the easiest way to do it is just check that the user ID that comes in associated with the transaction call to the smart contract
Mm-hmm.
has the authority, it's like an if-then check.
Is this in the YAML? So that YAML file would be a username and password, and it'd be like, he can mess with this property.
You would be in the smart contract layer.
Too easy. It's in the smart contract layer.
Yep.
So it's within the contract.
It's just, like, all it is just code. And it's basically a distributed interface of accessing programming logic. Like, smart contracts are, right now, you can write almost anything in the smart contract as far as logic goes. So in one application that we use, we literally have 6 credentials, like in this vehicle manufacturing one. It's the DMV, has a username and password, and that username and password is checked every time
With
the
if
transaction
then.
is sent.
If it's this user, if it's this
Yes.
password, you can do all the properties.
Yes, exactly.
Gotcha.
Yeah, and then that other method down below, that allows you to update the, whether or not it's been scrapped. The vehicle's been scrapped, that's like delete, right? So the scrap merchant has a username and password.
And
they
if
can-
then only gives
yeah,
them to
so-
the delete
yeah,
method.
Yeah.
Okay. This is a private blockchain. This is only the people that are associated with a car have this blockchain.
You have to have the user ID to make any updates.
So you have, so like user roles and access control, those are all defined in the contract, the
Yes.
smart contract, okay.
Huh.
And it can get increasingly more complex. You can have access control chain code just for that, and then you can, abstract the access control layer and then give that as like kind of the gateway to the different smart contracts that you have to be able to update the business object.
Can I see some code?
Yeah, you can.
So you could you have workflow
Right now?
in there? So could you have like, let's say,
Yeah.
you're the guy that paints the car, but the DMV has to approve it before it goes in?
Sure, yeah.
And that could be built into the smart contract, or some of it could probably be offloaded to the application to speed up the smart contract.
Yeah, absolutely.
Okay.
Yeah, it maintains state. So your car is in a state of half painted until the DMV approves that it's changed the color.
Oh, the person who issued the VIN at the beginning has to approve everything?
They
Not
could.
necessarily, yeah.
Theoretically.
Well,
I mean, they
her
could in
scenario,
my scenario.
it was.
Because
I'm just trying to
anybody
think
can
of
set it up however they
workflow.
want to.
Right, yeah.
Right?
Yeah.
So they could set up, they have to approve every change to the object, I'm just gonna call it object, the ledger,
Mm-hmm.
or the contract, that's what you're calling it, it's the contract.
Right, the chain, yeah, the smart
That's the object.
Um,
Yeah, anybody else wanna see code on this? I'd love to
Yeah,
see some
I'd
code.
like to see some code.
Well, let's
I'd like to
go-
see
Nobody else
Hello
does.
World or something that's easy to
I love
understand.
code.
I love it.
It's in Go, or what language is this in?
Yeah, it's in Go.
Oh,
They use
great.
Provenance.
Welcome to the future.
I won't be making this today.
Yeah.
Do you know
Alright.
Go?
No.
I don't know Go.
It doesn't
I'm
have
starting to
go.
think that we will no go.
Well,
Well,
no,
I
because
won't know
I'm
go
starting to
yet.
hear it everywhere.
John Flow support is it's here. I mean, it's on our doorstep and
Okay.
for Hyperledger, and you'll be able to write chain code in Java very soon. So this is, let's go to
So yeah, maybe one of the contracts, what do the contract look like in code, or what is the?
Yeah. Trying to think what I have legally allowed to show you guys.
And how does it move, like what moves? Is it yeah, I don't understand what actually,
The state
is
gets updated.
it just the state
Yeah,
that
it's a
moves
law state, it gets.
with the
updated.
contract?
All peers either agree or disagree based on the cryptography. If there's a signature involved. I'm assuming, I don't know anything about Hyperledger. But
Yeah, it's, if you have the certificate to make the changes, then you're part of the network and everybody can validate your certificate because they're also members of the network.
So what moves is the object? You just move the object to another person,
Yep,
and it, for all intents and purposes, whatever.
yeah. So that's kind of the genesis of blockchain is asset ownership and tracking of asset
Yeah.
ownership. So as that asset moves to that business network, and it's the life cycle of that asset, then you can query that that blockchain, see who owns the asset, see what the state of the asset is.
And the history's,
And-
with every movement, the history's there with it,
Yep, it's tied to it.
so it's not static.
Right. Well,
Well, it's static,
it's
but it
static
has-
in the notion that it's got state,
Right,
but you can always go trace that state.
with each instance, you can go back.
With each invoke,
Yeah,
is leaving a stamp in time, a law.
That goes with it.
Of changes.
goes with to everybody.
That goes out to everybody, yeah, has to, because everybody has to agree that the state has changed and update their own
What does
ledger.
that mean for them to agree?
Consensus.
Okay, but do they have to physically do anything?
No.
Or do they
Well,
just
unless
not
you have
say it's
workflow
not
in place.
good?
Consensus is just a matter of, we sync the ledger. So we
Okay.
send messages back and forth to each other, and we say, yep, looks good to me, looks good to me, looks good to me. All right, we've got 33% of people agreeing, commit. So now the ledger has been updated with the transaction, and then we're going to also keep, in our back pocket, the history of that. So we'll have a little breadcrumb, and as we move on, we validate a bunch of new transactions. We can always go back, pull out that card that says, oh yeah, 3 weeks ago, this vehicle changed color.
Yeah.
And we know it, and we agreed to that because it went through consensus.
The syncing, yeah.
Mhm.
So, going back to your DMV example, so when you said there are 100 been created and it is sent to data, so in the block, it will be sent to everyone, broadcast to everyone in the block, or it will be only to?
Right now, it'd be broadcast to everybody.
And then-
Just the VIN's empty until they put something on it, then it'd be broadcast to everybody that it had the car on it, right?
But-
So here's what I'm gonna do. I'll spin up, we actually have a demo that we can show you guys that is
Right.
That's what we wanna see.
vehicle manufacturing.
Yeah.
It's gonna take me a little bit to spin it up, but here's.
We'll come back.
Yeah, I'll do that. Brent, is that cool? Can
Yeah,
I-
definitely.
Is this classroom occupied?
No, we have the factory workshop at 12, but then
Maybe
we
this
have
afternoon.
this room until like 1:30, 2 o'clock.
Okay.
And then honestly, we can plug stuff in the main space as well.
Be cool.
Probably can put you guys in the conference room. That
Yeah.
would work as well if you wanted to break out
It'd be
sessions.
cool to see a demo.
I'll take
Yeah,
us through a
let's
demo if
see
people
too.
wanna see it.
That'd be awesome.
So you guys can ask questions and
So,
see what code is.
I don't think we're gonna be able to build that today or tomorrow, right, this isn't something we've just built in 24 hours.
Not with that attitude.
Fair enough.
So guys,
Fair enough.
the number
It's okay.
required for consensus is what's in smart
Damn it, I
contract.
gotta, my attitude.
That's, consensus is separate from
Yeah,
smart
it's
contract.
that.
It's a different layer.
Consensus 33%, that's like not
That's what-
real, that's not like the definition of consensus, right? So I guess that there's a consensus layer then that is defining parameters on which that's gonna be based for this block.
Pretty much, yeah. So in Bitcoin, it's proof of work, right? So there's, it's like a messaging protocol. It's like, do you agree with me? I agree with you. We're all just gonna move forward in this new happy state.
Yeah.
And if things are going bad, consensus also helps. So half the network says this, the other half says that. Consensus is like, guys, figure it out.
Yeah.
Like, we can't move forward until this is an agreed state.
Yeah.
In the Hyperledger project, there's multiple nodes and it's a decentralized network. How many actual nodes are there, and what happens if all of the nodes go off the network?
It depends on how many nodes you spin up. Right now, if you were to spin up a Bluemix version, IBM has a blockchain service, gives you 4 nodes, because that's the minimum required to achieve consensus. If one node goes down or is malicious, it'll still stand up. If there's only 3 nodes and one goes down, then it passes that 33% required agreement, or excuse me, 60%. It can tolerate 33% of the nodes being malicious before it breaks. So 34% of the nodes say are not coming to consensus with everybody else, then the network will close down if you're using Byzantine fault tolerant consensus protocols. But you can scale out, that's the whole point, right? Being able to scale out as many nodes as you need for enough redundancy to make you happy in the security and viability of your application.
Does that 66%, is that just an artifact of small numbers, of only 4 nodes, or if you've got
It's a
100
mathematical thing, it scales. Practical Byzantine fault tolerance is tolerant to 3F+1 failures. And that's just study, that's just a academic kind of thing.
Because if you run a blockchain and I can figure out all your nodes, I can do a DDoS attack all your nodes and you'll be off the network completely, correct?
Yeah.
Okay, so it's not technically fault tolerant, that's what I was.
But I mean, if you're gonna, I don't know that vector, honestly, that attack vector, but you'd have to have the credentials to send transactions that are going to slow the network down and hold us up, unless you take it from the outside.
Yeah, I was talking take it from the outside.
Okay.
I see what you're saying, I got you. You'd have to have authentication in the first place, gotcha.
What's up, man? Okay. Spin it up. It should, the default should be fine for you, man.
It's a 4 node, so I'm usually go to this node concept. So, where are these 4 nodes? Are them cloud somewhere?
Mm-hmm. Yeah, so we have dedicated servers that are partitioning off components that make up the node for you.
So if you were gonna use Bluemix for
Mhm.
this, what would you sign up for? Is there a Hyperledger service that you'd find?
Yeah, there's a beta, it's IBM Blockchain.
Oh, it's IBM Blockchain, okay.
It's built on Hyperledger though. So when you get IBM Blockchain on Bluemix, you're getting Hyperledger Fabric nodes.
Okay, and then that's what you would subscribe to, and then you write the contracts with Golang and.
You can push it out onto Bluemix
And you push
and
it
have
on
it run
Bluemix.
the contract in your Bluemix nodes.
So Hyperledger is just the database, right?
Pretty much, yeah, it's a database and communication protocols and things of that nature. It's that behind the scenes, and you build smart contracts. Smart contracts are part of Hyperledger as well.
So is that database decentralized or just owned by IBM?
If you use IBM Bluemix,
No,
if you use Hyperledger, you can, it's open source, man. You can download Hyperledger and run it on your machine right now.
You can try it for free, it says. Try blockchain.
Yeah, if you wanted to use IBM, but again, Hyperledger is an open source project. You can spin up a node without any company telling you.
You can spin that
anything.
without using Bluemix.
Right, so I don't know, I had a link to something there that would get you started. If you
Yeah.
go in the, read the docs page, you
Uh-huh.
can set up a DevNet, which gives you, I think, 2 nodes. You can't really run full consensus on that, but it allows you to build contracts, smart contracts, execute smart contracts, build the application layer, run everything locally. And if you wanted to then push that up to something more robust and secure, then you can go to Bluemix, or you can partition your own server space to run nodes for you.
Okay.
I mean, it's up to you, honestly. We have Docker images, you just put it on your own machine.
That's really cool. I mean, a lot of stuff.
Thanks.
Now, I saw on your card, it says Bluemix, not Bluemix, but Blockchain Labs
Mhm.
here in Austin. You guys actually, like,
We're-
have an office?
We don't right now. IBM has a big,
Yeah.
campus up there, but the Blockchain Labs is a global body.
It's like a research group?
Pretty much, yeah. We're the client-facing team for our Bluemix, or not Bluemix, our blockchain group at IBM.
Now, as developers apply this and build applications using this technology, is IBM got a program to bring those to the marketplace to help independent developers?
We're building that right now, yeah. EcoD, Ecosystem Development, and BizDev are 2 teams that I'm closely aligned with that are working to bring partners on if they're
Mhm.
looking to partner, things of that nature. If you need resources, maybe you want to you're a startup and you need more Bluemix time than the 30 days, which obviously you're going to, then we have programs to give you free or discounted
Awesome.
Bluemix resources.
Yeah, I'm interested, and I've been IBM partner before. I ran a company that was IBM Premier Partner a long time ago, Note Shop.
Okay.
So, you know, and I've always had good luck with IBM over the years. I think IBM's fantastic at supporting, you know, the entrepreneur. So, yeah, I'm interested, so
Okay.
I'll get in touch with you.
Alright, so it's-
Thank you.
It's gonna be
That's really
like-
good.
It's gonna be like really quick. So, the only thing I'm concerned about is like explaining where the Bitcoin comes from.
Where the Bitcoin comes from. So pop up your laptop now.
Okay. It's just like, I understand it, it looks over the nodes and it says, okay, I got it, this is, the blocks make sense, they compile all that stuff.
Google Coinbase transaction,
Okay.
because that's where the Bitcoin come from. And it's basically an explicit agreement written in code, because if you run the Bitcoin core, then you are running software. And in that software, there is the allotment of Coinbase. Coinbase transaction, Coinbase. Type like Bitcoin Coinbase transaction. Did you have a question? Are you-
I just want to introduce myself.
Yeah, we've met a couple times. I've
Okay.
come to Factive meetups.
Really?
Yeah.
Yeah, I remember, okay, I remember now, yeah.
Yeah.
Here's my contact. Of course, yes. I'm gonna forget.
Here, I'm Sloan. I'll give you a card,
Okay,
so
good.
we don't have to.
I'll remember this time.
I'm sure
Okay.
I'll see you at many more Factive meetups when I don't have to travel. That's usually what I like to do on Tuesdays. Is come talk to people about this technology,
Mm.
because you don't really get to do that at a bar. Unless
No.
Okay.
Well,
You
we-
would if you go to the
we-
bar with me.
Yeah, that's true.
I'd be
some,
like, tell me more.
Interesting people show up. A couple weeks ago, Ladar Levinson of LavaBit showed up.
Yeah? Yeah. I got invited to that, but couldn't go. I was traveling. It's kind of frustrating how much I have to go around and talk to clients. It really inhibits my ability to do real work. You know, I'd love to be part of a team here, but I can't. I just don't have the time. I'd be exhausted after 48 hours of coding. I have to go to New York on Tuesday kind of thing.
Okay. So, I just,
My
I'm
name's
not so
Karen
concerned
Kilroy.
with
I don't know what
Bitcoin,
Fractal
right?
does.
Just like
Oh,
the, you know,
it's
just
one
the
of these
process in
computing
general.
Of
blockchain
creating
technologies
cryptocurrency?
platforms.
Yeah,
I'll
it's just,
give
it
you a
just
speech
comes
on it
out
in
of,
20 minutes.
like,
Okay.
everybody asks me, like,
Okay.
where does it come from? I'm just like, it verifies the network and it produces the Bitcoin. Like, that's all I can say, but I don't actually know, like, its actual, like, mechanism for where the,
So,
you know what I mean? Like, if my mom gives me a
I've got
pic-
two answers for this.
Okay,
I've got the easy answer and the hard answer.
I want both.
Okay, easy answer is most Bitcoin transactions have an input and output.
Okay.
The output has to be slightly smaller than the input because that delta is the fee.
Okay.
Coinbase transaction is the first one in the block. And it's very special. It collects all those little deltas between all the outputs and the inputs.
The transaction fees?
Yes. And add those all up and basically from nothing to that. And so essentially it takes all those transactions and puts it into another collection address.
Let's go
in
back
place
to
of
a
it.
small